cold in here again tonight. It's really cold in here tonight, so that's why I've got my hood up. It's a little bit chilly in here just a second. Once it warms up though, I'll probably take my hood down. The real Rays Fury. How's it going, buddy? Network guy, Nicholas, Volvo. Guy from Cape Town. What's up, buddy? What's up? Yeah, I'm just going to wait for a few more people to jump on the stream and I'll explain what we're doing. John Mix, good evening, sir. Good evening, Jan, Tony, R-Rock You Rule, Dave, Mason 30, all the regulars, man. Got ourselves a little team going on here. My brain had a little glitch. I very almost went to spin my iron tip round with my fingers. Like my brain was like, spin it round, and then it was like, no, don't do that. You know, when you get those brain glitches sometimes, and you go to do something and then you think, well, that's stupid. Why am I kind of considering doing that? What's up from Alabama? What's up, Stefan? While we wait, the amp you benched yesterday that we guessed on the output, what did it actually perform? That was the fly, the one that I was whacking with a stick. That did 220. What was it? Something like 260 watts RMS at 4 ohms. That was with both amps. Sorry, both channels bridged. So yeah, its total full output was about 260 or 270 watts RMS. So it wasn't as terrible as I thought. I thought we were gonna see like 130 watts like maximum from the thing, but yeah, it did 270-ish, 260, 270, something like that. Which is a little bit better than I thought, but still not great for the size. When I compared the size of it to a little bander that I have that fits in the palm of your hand, it's like the size of a crossover, and it benches 280 watts. Although it doesn't sound quite as nice. It's like the fly is in a kind of really old-fashioned Class AB design, so it sounds quite nice. It doesn't sound too bad, whereas the bander has a bit of background hiss because it's a Class D. You're such a good electrician. Thank you, buddy. That means a lot. Old school speakers and subs on Class D amps and modern head unit. How does that sound? How does that sound? Alright, so there's a few people on the stream now, so I'm going to explain what the hell I'm doing now, and I'm also going to talk about some stuff from yesterday. So, yes. So, good evening all. So we are looking at the Lanzar 7K again, and this is the amplifier we were having some problems with. We got it working, it had a lot of issues. I found most of the issues. I got it working, it turns on, it does Class D switching, it makes audio, but one of the banks here, the high side drive wave is a different shape to the rest of them, and we were trying to figure out why. Many different theories as to why the shape was as it was, but we weren't really getting any closer to solving them. Nothing was helping at all. The shape was still staying exactly the same. Since that live stream, I took all the parts out of that board and I put it in another Lanzar 7K board, which I have here. This is a second one that's in for repair, and it works perfect on this one with no issue. So I know that I have a problem on the board somewhere to find. Since the live stream, I did find one shorted diode, and it is one of the diodes that's in parallel with the gate resistor, and what it does is it pulls the drive wave down sharply. Pulls it down sharply. Yeah, helps turn the FET off quickly. That was open, so that meant that when the drive was going to be turned on, instead of going through the gate resistor, it was finding a short path through the diode instead, and there was basically no resistor between the driver and the FET. But that wasn't what was causing the issue. I replaced the diode and it still works exactly the same. Hasn't changed anything. The drive wave still looks the same on the bad channel, bad bank. Sorry. So now, what I've been doing is I was running it for a little bit just now, and I noticed that the two inductors on the side that is bad were kind of getting a bit warm. So now what I'm doing now is I'm removing all 4 inductors from this amplifier. I could actually just remove those 2. Yeah, let's save us a bit of effort. Let's just remove those 2. Because this amplifier is designed in such a way that you can actually remove the driver ICs of the banks which you don't want turned on. This is really interesting. So I can remove these 2 driver ICs and leave everything else in place, okay? And it won't drive these 4 FETs, and they appear to be isolated. And if you turn the amplifier on, it only drives this side and not the other side, which is pretty cool. So I can leave 2 of the inductors in, and what I want to do is I want to turn the amplifier on and see what it does if the wave shape sorts itself out after I have removed the inductors, because it's possible that the inductors are faulty. They might have a short circuit in them somewhere. I did check them already for shorts and there wasn't any, but there could be one. Yeah. I need a bigger fly swap for this one. Yes, my friend. So, now that I've removed the inductors from that side, I can power it up, having removed the drivers from the side I don't want to operate, and it won't, these FETs won't get, they won't get switched on by the switching on this side. Because I tried this already by accident. I actually powered the amplifier up, forgetting that I had taken these 2 drivers out, and it came on and worked fine. I was like, what? And then I was like, I went to measure the drive waves on this side, and noticed they weren't there, and I was like, why aren't the drive waves here on this side? And it's because the drivers weren't in. So I was like, oh, cool, I can power it up without the drivers in on one side, and it still shows it on the other side. So that's a cool feature. That's, well, not a feature, it's just a cool phenomenon that works. So if we power this up and the inductors aren't there, let's see. Okay, so it's currently drawing nothing. So now if I apply the audio. Okay, here we go. So we should have exactly the same looking wave on here and here, pretty much the same. It's a little bit different. Yeah, okay. So the issue then that we were searching for many hours is in fact something to do with the inductors. I imagine it's something to do with the inductors anyway, because after I've taken the inductors off, the drive waves look identical on both those banks, and they weren't before. So it's very possible that there's something with the inductor here. Now, in order to diagnose inductor faults, what I'm going to do is I'm going to take my transistor tester here, and this thing can measure inductance. So I'm going to see what the transistor tester tells me about these inductors. Oh, and also, who was watching the in-phase amplifier repair? I sorted that out. I fixed that as well. Okay, so first inductor measures an L of 0.13 millihenries. 0.13 millihenries. And what does this other one measure? It actually measures exactly the same, 0.13 millihenries. So both these inductors do appear to measure the exact same. So if there is a problem with either of these inductors, it's not showing up with the transistor tester. Okay. So, because the issue isn't presenting itself to us with the transistor tester, one relatively quick thing that we can do here is we can swap the inductors over on the board. So I've got two here on this side that were heating up. These were the ones that were soaking up the current. So these two are getting a little bit warm on the board. This FET is heating up. So and this side was beautifully fine, looked perfect, no problems. So if I believe that the inductor might be the issue, I can take the two inductors from here and swap them over for these ones and put these ones here. So we can swap the inductors round, and that will then, if there is an issue with these inductors, it'll move the problem to this side of the board, and then this side will run clean. And so then that will tell me that the inductors are the issue. An inductor is basically a coil, sort of. Yeah, it's a coil of wire that induces a magnetic field, which then has the effect of applying a low pass filter to whatever signal is going through it. So, without further ado, let us continue removing the other two inductors. There are two more inductors on the board. You might see here, these two. I don't know their purpose exactly. I've never really looked into what the purpose of these two other inductors are, but I'm sure Nicholas will tell me in no time at all. So it could be these ones. These ones could be the fault as well. Or it could be something after the inductors. So after the inductors, before going to the speaker terminals, we've got a big capacitor here. Like I said, we've got these two inductors, there's a resistor, there's another smaller capacitor. So it could be something on the speaker terminal end. But we're going to do things step by step, and we're going to, first of all, we're going to do one thing at a time. And we're going to first of all swap the two inductors over so we can see. Extra filtering, okay. So yeah, the in-phase works perfectly fine now as well. I just need to wait for those capacitors to arrive. I had to order some extra capacitors for that amplifier. Good evening, Henrik. How's it going, buddy? Yeah, we live by those low frequencies, don't we, John? They consume us. Why is it that humans love low frequencies so much? I have a theory. Why we like bass, and that is that to produce low frequencies like that, the loud low frequencies, they are a natural symbol of power. Like, so in order for those frequencies to have been made in the wild, it assimilates power would have been required to make those frequencies, whether that's some earthquake or some very large heavy mammal or object hitting the floor, so something like that. So in our nature, in our genes, we associate low frequency sounds, especially if they are high amplitude, with something powerful. So a larger animal would have a deeper roar or deeper growl, or it would stomp the ground and make a much lower frequency tone. So I think that because humans like powerful things, we like powerful cars, we like being powerful, we like powerful electronics. You know, we like having power even if we don't really need it, like with the car thing. So I think the low frequency, the bass thing, is all about having power and feeling power and using large power. Okay, so the 4 inductors are officially out of the board. Just with all 4 out of the board, I'm just going to plug her in one more time and compare all of the waves from all 4 banks and see if there's any deviations. So what we're looking for is, we've got one bank here that appears to be different to the rest of them. So I'm going to see whether there's any deviations in its characteristics with all 4 inductors out of the board and all four channels playing. Oh, sorry, all four banks playing. I keep calling them channels. They're not channels. They're banks. All right, so let's power her up. Just make sure that there's no solder bridges or anything like that under here. Nope. Okay. So we're going to compare the waves now of all 4 of these banks with the inductors out, and we're going to check for continuity. Okay, so Class D switching is activated. Wow, we're drawing 5 amps. That's a bit more. So it's actually drawing more current than when the inductors were in the board. Interesting. .8. Okay, so the output of the low side looks like this. I'm just comparing between banks to make sure it looks the same. Yep, and the high side drive looks like that on one side, that's on the other side. Huh, interesting. It does look a little different on this bank. There is a little bit of difference there on that bank. It is a slightly different shape. And why is that still heating up? It's... Whoa, holy fuck! Okay. Wow, okay, so the FETs don't like not having the inductors in the board. They get pretty hot. Wow, interesting, okay. Okay, so the FETs don't like not having the inductors in the board. Which would explain the extra current draw. They all run pretty warm. Alright then, so let's swap the inductors round now then. So now that okay, look, I'm going to show you the scope just real quick. I'm going to turn her on again, but not for too long. So, for people that know this stuff, Nicholas and others. So on the bank that had the slopey high side drive, okay, without the inductors in the board, this is what the drive looks like on the one with the inductors out the board, on the bad one, okay? So the bad one looks like this. And the good one looks like this. Okay, pause and change. Pause and change. Now you see how the step is not as sharp. You see how that's a curvy step. Look, if I put this and zoom in. Okay, so look, if I put this here and I zoom in. Okay, so see this curve? That is curvy on the bad one, and on the good one, it's much sharper. It's very, very slight. It's a very slight difference, but it is a difference. And the only reason I say that that's a difference is because every single other bank has a nice, sharp step. It looks identical. So all the other banks look identical, and the one that's giving me grief does not look identical. That's just something for us to look at, perhaps. So it's possibly not the inductors, because there is still a difference on that one bank. Show the gate drive waveforms. The low side waveforms. Yeah, sure. The low side waveforms all look really, really nice. But I shall show you anyway. Okay, so the low side drive waveforms look like this, and the output from the low side looks really good. So rare. Okay, pause. Start. Yeah, you see how we've got a little spike on there. But that's on every single one of them. So the reason that this thing's heating up now is because we've got a tiny spike on the low side drives. But that's that must be something to do with the inductors not being in. But just to confirm, it looks the same on the bad side and the good side. So the good side, low side looks like this, and the bad side, low side looks like this. Yeah, it looks identical. So the low side drives look identical. And the reason they're getting heated up is because there's now a step in the low side drive for some reason, because the inductors aren't in the board. So they must be doing something to assist with the low side drive as well. With the inductors in the board, the low side drive looks very good. Evening, Chris. Should get your amp back soon. So now let's, just out of curiosity now, what I'm going to do is take these two good side inductors that were on the good side and put them on the bad side, and put the ones on the bad side on the good side. And that might tell us more of a story about what's going on here. Yeah, everything's not bad. I'd love to get this Lanzar finished, because we're so close with the Lanzar now. It works, but just not quite how I want it to. Okay, so these were the good side ones, so let's put these into the bad side. So Nicholas isn't sure that swapping the inductors around is going to make any difference. I'm not sure if it will either, but I've got to start somewhere. the inductors on the bad side were heating up, and the good side ones weren't. So I'm just like thinking to myself, and the inductors were also very wobbly. They were like very, you know, they're wobbling around on the board when it came in. So it's possible that they may have shorted something. But I'm wondering what's causing that wave to have, like, because with the inductors out the board, the batch that's bad still has something different on the top of the wave, doesn't it? It still has something that's slightly different on the top. Very strange. Okay, that's one. Now we get the second good one from the good side. And from the good side, yo. Sam, Josh Hanson, I got hold of a Taramps. I got hold of Taramps about the HD 8K and asked about the PIC, and they said for me to take a picture of the board and send it to them, and they will send me everything I need for free. That's awesome. See, that same thing happened to me. Taramps are flipping amazing. Taramps are flipping amazing. They send you not only the PIC for free, but they also send you the whole repair kit for free. So Taramps will send you like output feds, power supply feds, gate resistors, power supply drivers, output gate resistors, all for free. And that is good customer service. You don't even have to be a repair tech, you just have to be a customer. They'll send it to you for free. Alright, y'all, so that's the inductors from the good side, now switched and put onto the bad side. So, let us now remove the drivers from the other bank that we don't want to switch on. Because that's cool, we can do that, isn't it? And let's power her up and let's see whether that's changed how this dodgy bank is acting. Nicholas doesn't think it will. I am skeptical as well, but I'm running out of ideas, so we've got to start at the very top. Okay. Please work. Please be an inductor issue. That's easy to fix. Oh man. Alright, so it's not the inductors then. Okay, it's not the inductors. Something else. And I don't think it's anything after the inductors, because that bank was different before we put the inductors in. It had a slightly different curvature on the step on the way down. Measure for small resistance on each pin. Reference to what? Ground? Or reference between each other? Pin 1, 2, 6 and 7. Solder them direct to the PCB. Oh no, that's no, because then I can't swap them round. I want to be able to swap them round. It's not the headers that's making the issue, because the issue is not present on this board. This has headers in it. Maybe if I reflow the solder connector at the headers. Ah, contact resistance, okay. Okay, so that means I need to flip the board over and check. Okay. I'm not sure how I'm going to check for small resistance there. Alright, let's hard solder this one driver IC that's giving us a headache. Let's solder this directly into the board, okay? Just in case the header is not doing its job properly. I don't think this is the issue, but let's see. Alright, cool. So I don't have any spare headers for these, so I'm just going to solder the chip directly into the board. So just in case there is some issue with this header, because I can't find a bad component anywhere on the board for this. So yeah, let's oh, why has that gone out of focus? So we're just removing the header that the chip goes into, and I'm just going to solder the chip directly to the board. I really hope I finish it today. Thank you for all the kind words. It could also be a bad via, I guess, couldn't it? It could be a bad via, which means we'll be here all day. Ah, it's nice and warm in here now. Okay. So soldered the IC directly into the board rather than putting it into headers. Does that make a difference? So the amp is not happy about something. It's not actually coming on at all now. What's the amp not happy about? Oh, for fuck's sakes. Pay attention to what you're doing, guys. My bad. Fuck's sakes. Fucking chips in backwards, upside down. solder it all, put it back in again. I guess we're only human. These things happen. Are you still using the computer motherboard that you fixed the traces on? Yes, I am. This driver IC could now be toast. I agree. So rather than put this same one in, I'm going to choose a different one to put in place instead. Just in case I just toasted this driver IC by putting it in backwards. I don't think I did. The amplifier was straight into protection. There wasn't even a hint of rail voltage. It didn't even try and turn the power supply on really. Oh Jesus! Even though I've done all the pins, this is still really stuck. What the fuck? Oh, this is why I love headers so much. I don't get any of this crap. Yeah, so I'm going to put this IC down to one side in case I just killed it by accident, and choose a different fresh one. Right, that way round. Fuck you. Yeah, we're good. There we go. That should works again. Alright, so yeah, IC is now hard soldered to the board. So did that make any difference? Nope, no difference. No. So you see here, right? So anyone that knows stuff, so the good wave should be sharp up with a small step, and then slower down. It's more slopey on the way down. The bad one is sharper on the way down, but more slopey on the way up. It's almost like there's a backwards diode somewhere. Look, slopey down, sharp up. Slopey up, sharp down. Bad. Good. Bad. It's like they're mirror images of each other. Good. Bad. Good. The part number is IR2113. Yeah, it's pretty much the same as the 2110. That's the high side drive, yeah. That's the high side drive. So the high side drive is supposed to be sharp up and slopey down. Instead, it's slopey up and sharp down. It's almost like that there's a diode that's backwards. So a diode that should sort out the sharpness of the FET turning on. It's almost like it's backwards, and instead of sorting out the sharpness of the FET turning on, it's sorting out the sharpness of the FET turning off, but making it slower to turn on through a resistor. The wave looks considerably better than what I remember from before. Nah, it's exactly the same. It's just the way it looks on camera. We haven't made any progress at all. It looks exactly the same. The amp's still drawing the same amount of current, and yeah, the FET is still heating up. The stupid thing is, right, the stupid thing about this is that we have the key, we have the answer. This is the answer. This is a fully functional working board that doesn't have the issue that this one has. But no matter what values I compare, I can't seem to find any differences, anything that deviates from one board to another. Everything I read, diode readings, resistance set readings, everything is exactly the flipping same. I'm just going to plug the other board in. So this is the good board. So I've actually swapped out. I've actually got the 38N30s on this board instead of the 24N40s. It did used to have the 24N40s. I've just quickly put on some 38N30s just to see. Ah, I don't have a driver board in this amp. Stupid. What components are between pin 7 and the gate of the FET, as well as on pin 5 and FET source? Okay, I'll have a look at that in a sec. Okay, again there's no drive now. What the fuck? Why is this not working now? The fuck? This board was working yesterday. Oh, it could be that I put it into slave by accident. That could be what it is. There we go. Yeah, I put it into slave by accident. Alright. Right, okay. This is interesting. Right, this is some extra information then. Okay, this is interesting. And this is possibly what the issue is. Okay, so Nicholas, my friend, do you remember when we looked at this the first time and we put the 38N30 FETs in the board and there was some nasty spikes on the low side drive, and you said you thought it was because of crosstalk, and so between the FETs there were different specs, different spec FETs, so I took the FETs off and I put some different FETs on that were a different batch, which is why I've got 24N40s in this board, and that resolved the issue, but it didn't get rid of the issue with the high side having a slope. I've just taken the exact same 38N30 FETs that were giving the crosstalk issue and put them onto the good board, and it works beautifully fine. So the FETs are fine. There's no deviance of crosstalking with the FETs. Look, so right on this board, right, I'm going to do this to show you exactly what I mean. This is the good board. This is the board that works. This is a perfectly fine, fully functional output section board. When I turn this on with 38N30s, and I'm going to probe the high side drive. The low side drive looks like this. It looks beautiful. We have a little step down, a nice sharp steep upward, and a flat top, and instantly off. And that's the same on every single low side drive. Looks exactly like that with no weird glitches or steps. The high side looks equally good. We have this on the source, we have a nice sharp square, And on the drive we have a sharp up, a little rivet there, and a sort of more slopey down, but it's relatively equal. So this is a good, fully functional, fully working board with 38N30s. If I remove this board now, okay, I'm going to remove this board and I'm going to put the driver, I'm going to literally put everything that's currently on this board, I'm going to put into this board that's bad. Drivers and all. Okay, so with 38N30s, this board works perfectly fine. So the 38N30 FETs are not a problem. So I'm going to take the 38N30 FETs, I'm going to swap them, and I'm going to put them on our bad board, because the 38N30 FETs appear to be showing up the problem far better than the 24N40s. I'm going to put them in exactly the same places as well. So I'm literally just going to take the FETs off the board like this, put it there, take the same one off on this board, take the same FET off, put... Actually, I'm not going to bother putting it on the good board because I know it's good. So I'm just going to put these back away. And I'm going to put the FETs from the good board in exactly the same location as they were on the good board on the bad board. We will get to the bottom of this if it kills me. I want this series to be over. Can we start a new series? This is like some never-ending TV series where it just the problems just never get solved. Okay, so that's those four fitted. So we're going to spin her around, and likewise on the good board, spin her around. This is quite a challenge. I do like these ones that are a challenge, because the ones that are a challenge, you always learn something after you finish fixing it. So when we finally get round to finding what the issue was with this one, I will have learnt, and hopefully you guys will also have learnt, what to look for if you have a high side drive that doesn't look right and looks how we've got here. Then you'll know what to look for. Okay, so that's all the 38 N30s off of the board that just worked beautifully fine. I'm just going to put the other two inductors back because they didn't make a difference, so the inductors aren't the problem. So I'm going to put the other two inductors back on the board so that we can power up fully again. I'm wondering if a PCB, if the track on the PCB is cooked and has a higher resistance than it should be. Oh, it's possible. It's very possible, because there were some cooked tracks on this board. There were some cooked tracks that we fixed. So maybe there's some elsewhere that. This is dramatic. Yeah. So I if you just joined the stream more recently, I actually removed and swapped over the inductors in case it was the inductors that was causing the problem, but it wasn't. The inductors are just fine. You're just fine, aren't you, my little inductor friend? I'm fine as hell. There's that bass again. If anyone's got a sub, that would have sounded quite interesting. Evening, DJ H. Yo. Hope you enjoy the rest of your day at work, Jesse. You always catch a little bit of my live stream on your break first, don't you? And then you catch me later on. I'm not sure how late I'll be streaming tonight. I have got some other shit to do this evening, which is non-amplifier related. Depends how we get on with this Lanzar. Like, I've kind of got to get this fixed tonight. Because I have a deadline on this, because someone is leaving the country and needs it fixed before he leaves. So I really must fix this tonight. Yeah, so that bass is a bus, is definitely a bus at idle. If you're not a regular on the stream or you haven't heard me say that before, yeah, that bass that you hear is the bus outside my house. I have a bus stop outside my house. It builds a beautiful sine wave in the workshop when it idles outside my house. Okay, so all 4 inductors are in, all the FETs are in, drive board's in, all 4 drivers are in. So now this is where it gets interesting. This is the bit where we show you the issue, but the issue is now elaborated, it's enhanced, okay? So these 8 38N30 FETs in the exact same locations they were in on the good board are now in the bad board. All 4 inductors are good, we know that. All 4 drivers are good, we know that. So this should just work, but obviously it doesn't. But the issue is actually now worse with the 38N30s. Whatever the problem is on this last bank, whatever the problem is, it's worse with the 38N30s in the board. I shall show you what I mean. Okay, so now, with the 38N30s in the board, the low side drive wave looks like this. See that massive step? Okay, so there's a massive spike in the low side drive on this bank with the 38N30s in the board. On all the other banks, it's not present. Look, so if we go to another bank here, check the other bank. It looks beautiful, but on this bank, the step is present and we have a slopey high side drive. And the FET heats up like fucking crazy. Like, the FET is really, like, it's the FET that gets really hot. The FET that gets really hot is this one. It's the FET with the high side drive on it. So the FET that has the high side drive on it gets silly stupid hot. The amp draws like 7+ amps. The driver doesn't get hot. Let's take a quick sneak peek at that high side drive, but I don't want to leave the amplifier on too long because it gets really hot. Wow, look at that curve! Holy fucking shit! Right, oh, fuck it. I want to try and pause the scope, I don't want to leave the amp on too long. Okay, come on, let's do it again. Stop. Okay, right, so that is a huge curve on the way up. And that is probably also caused by the low side drive having the massive spike in it. But the low side drive FET is getting hot now. So both of these FETs in this bank do heat up. The high side drive FET heats up more than the low side drive. Like, it's too hot to touch now. So the high side drive FET heats up to almost too hot to touch. And the low side drive FET is just kind of heating, probably as a result. Maybe the heat is actually passing through the board on the PCB, and that's why it's getting hot. So yeah, just for reference, the high side drive wave should look like this. Okay, so that's what the high side drive wave should look like. But instead it had the massive curve on the way up. So yeah, so that's what we need to find and sort. So let's see what Nicholas is saying, because he usually has some great advice, because he knows much more about it than I do. Verify total resistance from pin 7 to FET gate and pin 5 to FET source. Alright, look, wicked, let's do that. Let's do that. We're at the point now where I'm kind of running out of ideas. And Nicholas has the ideas now. With the 38N30s in the board, I could actually probably use the thermal imager and see what else is getting hot on the board. Something must be getting hot on the board other than the FETs. So we're checking for resistance between from pin 7 to FET gate. So pin 7 to FET gate. So 1, 2, 3, 4, 5, 6, 7 and FET gate, and that's the high side gate. So the total resistance between there and there, 71.5 ohms, or 71.4. Let's compare with another bank. (71.4, 71.3), so it's pretty much exactly the same. And pin 5 to FET source. 1, 2, 3, 4, 5 to FET source. So my meter shows 1, 2, 3, 4, 5. My meter shows 1.5 on this one, and on the other one it shows 1, 2, 3, 4, 5. 1.5, so exactly the same. Yeah, no, it's because my multimeter has a test lead resistance of 0.6. So all the other banks do read exactly the same. So the actual resistance is 1 ohm between the source and the driver IC, and that's how the circuit's designed. If I measure it on this one as well, this other side, the other side that's never had any problems at all ever, it's been perfect. It is, well, where are we? High side, what are we? 1, 2, 3, 4, 5. So yeah, the other side is 1.5 as well. So that's actually about 0.9. Because my test lead resistance is 0.6 ohms. Okay, so for anyone that's just got here or just come back, we're looking at the Lanzar 7K Opti again. So we struggled with this the other night. The other night we found that the amplifier worked, but we had issues with the drive on one bank. The high side slope, the high side drive slope was too sharp. The drive wave should look like this. Instead it was very slopey on the way up, and it was causing that bank to heat up. We literally tried for ages and couldn't find what the issue was. Since then I found a shorted diode on another bank, but it was irrelevant. It wasn't causing this issue, but I replaced it anyway. And we've tried some other things, including swapping all the inductors around in case it was an inductor issue, a few other bits and pieces, and we've worked out that putting the original 38N30 FETs in the board enhances the issue. It makes the issue worse, which is easier to troubleshoot because it presents more of a problem. Things heat up a bit quicker and the waves look worse, which is easier to diagnose. And the exact same FETs and the exact same parts in a working board. I have a good board down here that works perfectly fine, and this works fine with the same parts in it. So we know that there's a problem on the board somewhere, and that's what we're trying to find just now. What's the gate drive resistor value? It is 62 ohms, I think it is. Yeah, so the gate resistor is blue, silver, black, gold. I think it's like 62 or something around that mark. But it goes through a 10 ohm resistor. So the drive goes through this 62 ohm resistor, which is in parallel with a diode. Then it goes through two 5 ohm resistors in series. Weird. Yeah. I am going to try, there's something that's been on my mind a little bit. There's a diode that's been on my mind a little bit. I'm going to try and change a diode that we haven't looked at yet. The diode that I'm going to try and change is, so when we were looking at this this drive area, this output area, we were looking and we changed this diode here, which is just hiding behind this resistor. But we never changed this one. And this one could be the bootstrap diode. So I'm going to just try and swap this one. Just in case the one thing that we didn't change, Sod's Law, happens to be the one thing that is the issue. What brand is your iron? It's a brand called AOUE. AOUE. That's the actual brand of my soldering iron. AOUE. I have no idea how you're meant to pronounce it, but that's how it's spelled. Nidfrost, what's up? Yeah, what's up, Nidfrost? Nidfrost. I'm curious. So I'm curious as to everyone's YouTube names, YouTube handles. So Nidfrost, what's that? Where does Nidfrost come from? What's the reference with Nidfrost? Let's look at people's YouTube handles. Nidfrost potentially sounds like a air conditioning unit company brand. Now, Nicholas, we changed the other diode, but we never changed that one there. We changed the other one, but not this one. I think there might have been some confusion as to which one was the bootstrap diode. But either way, I'm going to change it now. Nidfrost says, I need frost. Is that actually why? The real Rays Fury. I just like the name. Yeah, that one sounds pretty cool. D303. No, so the diode that we changed before was D302. So when we were looking at this before, I think because I don't know the detail of this circuit as well as you do. So this is the diode that we looked at before. This one here that I was touching and making connections to, and you said that to try changing this one. I never tried changing this one, so I'm going to try changing that one just out of pure interest. Need frost. Well, base Natix is obvious. What else do we have? What other interesting handles do we have? The ones that are obviously not names. Random flat shows videos. I have a rack mount American audio that goes to protect mode when playing at low volume. What seems to be the issue? I don't know. I don't know rack mount amplifiers well enough to advise you that over the internet. Volvo Steph, I imagine you like Volvos. Most are just names, actually, aren't they? Initial Pro. What's that one from? What's Initial Pro all about? Yeah, most of it's just names nowadays. Ah shit, I'm getting told off by Nicholas. Sorry, I must have got confused. I must have got confused as to which one was the which one we were talking about being the bootstrap diode. Because I thought we decided it was the other one. Okay, well let's change it then. check the live chat history in your time. That's right, man. I believe you when you said to change that one, because I probably missed it on the live chat. I totally believe you. You probably did say to change it. I probably missed it, so that's my bad. All right, let's measure it on the tester just out of curiosity. See what it reads. So my YouTube handle, BearVids, I actually don't like it at all. I don't like the BearVids handle. So I made the YouTube account back in 2000 and I think my first video was in 2006, but I think I made the account. No, I think I did make the account in 2006. Just for people that are interested, this is what the diode reads as on the meter. Doesn't mean that it's good, because sometimes diodes, they read fine and they're actually not any good. So let's put that to one side. I'm going to steal the equivalent diode off of the other board that works perfect. D303. So I made the YouTube account in 2006, and back in 2006 I think I was like, wait, hang on a minute. 2000, where are we now? 2000, with 2018. So I'm 26 now. So 2016 was 12 years ago. So 12 years ago I would have been 26, 16. I would have been 14 years old. So I made the account when I was 14 years old, and the whole idea of the account was to upload stupid videos that I'd taken of my school friends at school, in the playground and stuff, of us just being stupid and messing around. I needed somewhere to put the videos online so that so my school friends could watch the videos of us pissing around in the playground. And at the time, slang, I don't know if it actually was worldwide. I think it was pretty much just a UK slang. Bear was a UK slang word for many or multiple, like many things. Like, it was a sunny day and I had bear ice cream. I had lots of ice cream. Bear was a slang term, and still is kind of used, but not really used much amongst like school kids for many. And so my YouTube handle was bear vids, as in like, many vids, loads of vids. That's where the bear bit comes from. But obviously then I started filming videos of my sound systems and shit. And when I was a kid, and other kids seemed to like the videos I was putting up. And then we all kind of got older together, and the content changed as I got older, becoming more kind of experimental. And as I got a bit more knowledgeable about audio, I started doing videos about boxes that I'd built and stuff. And so the kids that started watching my channel when I was putting up silly videos of like home theater, like cheap crap subwoofers and stuff like that, ended up being followers and followed my progress as time went on. But yeah, initially, so the reason I don't like the Bear Vids YouTube handle is because it has nothing to do with audio, and I only made the channel Bear Vids because at the time it meant, well, many vids for my school friends in the playground. But you kind of stuck with what you choose, isn't it? Like, I couldn't change my YouTube handle now. Everyone knows me as Bear Vids, so I couldn't change it now to something else. I did consider at one time changing it to NSV Audio, but I don't know, people just know the Bear Vids thing. Yes, this is true, there are now Bear Vids on my channel. My channel now does contain Bear Vids. Alright, so bootstrap diode has been changed. I'm gonna feel like an idiot if this works now, because I obviously missed Nicholas telling me to change this one separately a while ago. So excuse me. So if this works, I'm gonna feel like a bit of an idiot. Okay, plug her in, and moment of truth then. No, doesn't make any difference. It still looks like shit. So, it's not the bootstrap diode that's causing it then. So I'm going to take this diode that I just took off the good board and put it... Sorry, I took the diode off the bad board. I'm going to put it into the good board so I don't lose it, because it's obviously fine. I'm going to do that while I wait for the other board to discharge. What I'm going to do in a moment is I'm going to turn the amp on again, and I'm going to have a look at it through the thermal imager. See if I can see anything else heating up around that area. I might actually be tempted to email Perry Babin about this and see what he thinks. He's very helpful if you word your questions correctly. What was the part number on the driver ICs in the headers again? It's an IR2113 is the driver IC. IR2113. Alright, so let's power this board up again. I'm going to have a look at some temperatures through the thermal imager. So obviously this FET is getting crazy hot. So we're going to try and have to ignore that while we look at it. And try and look at anything else on the board that might be heating up. This thermal image is not really very good. I probably should have got a FLIR. so you can see the two drive waves together. There we go. These are the two drive waves together. So this is the high side that's taking too long to turn on, and this is the low side that's got a spike on the way up. Ignore this bit of noise at the top here. That's not meant to be there. That's not relevant at this point. So the FETs are, the original part numbers are 38N30. The ones that I was pissing about with before were 24N40F. I really enjoy your videos. Thank you very much. I would enjoy doing the videos more if this wasn't such a bitch to repair this one. This is really frustrating because this is one that I need to repair quickly as well. It's not useful when the thing you need to repair quickly is like the thing that's taking forever. Okay, FET reaches 65 degrees very quickly, 68 degrees very quickly. It still does look like some other things on the board are heating up. For example, this resistor. Perhaps. Maybe not. It's very difficult because the problem is the board itself, the actual PCB itself, is heating up as a result of the FET heating up. So it's very difficult. Now, leaky caps, we've changed all the caps around this area in the drive circuit that may affect it. So we've tried changing this cap, this cap, this cap, this cap. We haven't touched these two. These are to do with the output, the speaker output circuit. Yeah, we've tried changing all the caps around the drive area here. This one as well, I think I changed. Base at 30. That question doesn't make sense, so I can't answer that. Protection chips don't make it 0.5 stable. The board design and all the components used together make it 0.5 stable. The protection will be calibrated to cut into protection mode if it has a current limiting protection mode. Then when it detects that the current has exceeded a certain limit, then it will throw the amp into protection. But usually that current is way higher than than doing a bench test at that impedance. So for example, with a 1 ohm amplifier, I can drop a 0.5 ohm bench test and it actually plays and doesn't go into protect. So I think the excessive current detection is either quite slow or it's set quite high. We check R468. Where's R468? Oh, this one. So this one, yeah, it looks a little burnt. It did get a little bit hit, but from memory it doesn't have any of the drive waves on it, and it also measures the perfect resistance. So I could try and change it. It did get a little bit warm before when the amplifier died, obviously. There's quite obvious signs of that. But I don't believe this resistor to have any influence on the drive wave. It's the low side drive and things like that that's having the issue. Let's see what's on this resistor. I believe it's just the high side to ground or something. Let's see. So yeah, it's just DC to ground, so it's not having any impact on the wave. I think it's a pull down resistor for the main rails. Weird that it got hot though. Yeah, that green resistor is still well within tolerance. It's not, it reads perfect, so that's not the issue here. I'll change it if you want, but it's not the issue. Could you take some pics of the top and bottom of the PCB and send it to me? The driver and MOSFET area. Yeah, sure, man. Thank you very much for offering to look at that. That's cool. I'll snap some high resolution pictures of that. I mean, I guess what... Oh, fuck. That's very hot because I just soldered it. Okay. I guess... Obviously, this is a working board. This is a non-working board. What we could do is we could do a very lengthy process of just swapping out every single component one by one, swapping, drop, swap, drop, until it starts working, and so then we'll know what the issue is. Base at 30, there's no such thing as a complete short circuit. You're forever getting closer. It's, what's the word? There's a word to define something that forever gets closer to something but never reaches it. Exponential, I think is the word. So, yeah, 1 ohm. So, you say you've got 1 ohm. 0.5 ohm is then doubly closer to a short circuit. Then 0.525 ohm is again twice as close to a short circuit. Then 0.125 ohm is twice as close to a short circuit. And you go on and on and on. You get closer and closer, but you can never reach 0 ohms because there's no such thing as 0 ohms unless you have superconductive material. So, yeah, the closer you get to 0 ohms, the higher the current will be at a given voltage, but you never reach 0 ohms. So you just keep getting closer and closer, and the current keeps getting higher and higher and higher. It's nothing to do with the short circuit. The current protection will just kick in when the current exceeds its set limit. Yo, Greg T, how's it going? This is Lanzar Opti 7K. This is the one from a live stream a few nights ago, and we're still having the same problem with it, and we're trying to find out why. The reason that we're spending so long on this amplifier to get it working and to find the problem is well, obviously it's a customer's amplifier, it's quite a big amplifier, and he needs it back by a certain time. Secondly, this is an issue that I would quite like to know the cause for. Knowing the cause that causes this issue will be very beneficial to me in the future, so I want to fix it so that I can enhance my knowledge on what causes this exact problem to occur, because I would quite like to gain that knowledge. And so there's a great opportunity for learning here with this amplifier, and I would quite like to take it, and I'd quite like to beat it so that I learn from it. That's what you should do. You should consider every struggle an opportunity to learn something. If you can overcome and if you can sort the problem out, then that's some awesome information and knowledge that you have gained. That's an interesting idea. Have you tried soldering the FET in the other output paired position? I haven't, but let's try that just to see if that makes a difference. That's an interesting idea. I like that idea. We're going to try that. See if it makes a difference. I don't think it will make a difference, but it's a good idea. It's something simple that we can just quickly do. So let's do that just now. Let's swap the paired positions around for these FETs on the output section here. So we've currently got it here and here, so I'm going to swap it and put it here and here. I'm going to need to lift my amp up here to do that. Desoldering wicks way better. Not in my experience. I much prefer the speed and ease of the solder sucker. Much easier for me. And the solder sucker doesn't cost anything either. You don't run out of it. It's just always there, always does the job, always ready to go for you, never lets you down. I have tried solder wick and didn't get on too well with it. Right, so I'm trying both those FETs in their other paired position now, their other parallel position, just in case it makes a difference. Bevis, have you voltage referenced VB, VS, and VCC on all the ICs. Yes, I have. It's good. That was one of the first things I did when I was troubleshooting the voltage regulator. I had a look at all the... after I troubleshooted the voltage regulator and fixed that, I checked all of the voltage on the ICs, and they were all good. We can do it again though if you like. Yeah, we'll do it again. Now that we've been messing around with different things, we can do it again. I have a pile 30 watt 2-channel amplifier, each channel is 15 watts, and I have a 30 watt subwoofer. Can I connect both channels together? You should be able to bridge the channels, but make sure that the impedance is correct. I like the spring-loaded plungers. They work really well for me. I don't trust anyone more than anyone. Yo, App Store. Hi. Why no more bass videos, only amp repairs? Because this is a better direction for my channel. It's become more popular, and I'm giving knowledge to the community for free on my daily work. This is what I do. So it's either amp repair videos and subwoofer repair videos when I get time, or just subwoofer repair videos when I get time. Or sorry, subwoofer videos when I get time. So I'm not doing amp repair videos in place of subwoofer videos. I'm just doing amp repair videos as well as. So I would be doing this shit in my workshop anyway, every day. This is what I do for a living. So I would be doing this in the workshop every day anyway. And there would be a lack of subwoofer videos because I'm very busy at the moment. So I can either not film it and just have like 3-month gaps in between my subwoofer videos, or I can give this information to the community for free and have great fun whilst doing so, and still do the occasional subwoofer video every couple of months at the moment while I'm so busy. I don't have to change the other bank positions. No, I can leave them where they are. It's not it doesn't make a difference. Okay, cool. Let's go again and check then. Has replacing, so just for anyone that was interested, people who pointed out R468 as being slightly burned. I replaced it with a fresh one, so let's see whether that makes a difference. Nope, still looks the same. So swapping the bank position and changing R468 doesn't make a difference. Still the same shit. So this is what we're dealing with, and this is what we're trying to fix. We're trying to get rid of the slope on the way up on the high side. We're trying to get rid of the spike on the low side drive. These are our problems. These are our problems. This camera is such a fucking potato for my scope. Such a crap camera, this scope cam. Yeah, bass videos with subs in my own car. I'll resume that, but my car has currently been in the building process for 2 years because the guy who's doing it is so slow. He's very good, but it's very slow process. So that's why I haven't had a subwoofer in my car for like 2-3 years. So that's why I haven't done a video of it, because there hasn't been a subwoofer. I think the voltage on pin 6 with ref to pin 5 of the driver IC is a bit low. Could you measure the voltage with the multimeter? Yeah, sure. So, voltage on pin 6 with reference to pin 5 on the driver IC. Nicholas, I'm gonna probably have to do. Can I do this with the Class D switching not oscillating? Because otherwise it heats the FET up too much. I'm gonna try doing it first without clicking the amplifier into operation. So voltage on pin 6, referencing to pin 5. I still have my Proton, yes. My scope is a HP 54602B. 54602B. And it's by HP or Agilent, it's the same company. So, okay, what are we looking at here? We're looking at the voltage on pin 6. 1, 2, 3, 4, 5, 6. Reference to pin 5. Okay. Voltage on pin 6, reference to pin 5. Ah, stop slipping. So on this one, it's nothing. 0.4. 0.5, it's slowly climbing. So if I check that compared to another one, so voltage on pin 6, reference to pin 5. Oh fuck! We've got 2.3 volts on a good bank. No, yeah, that's a potential issue then. 2.3 on a good one. And 0.7 on this one. What the fuck's going on there then? Right, so pin 5. Okay, so pin 5 of this one is nothing. No, sorry, it might be something. I've got it on AC coupling. Sorry. So, where are we? There we are. DC coupling. So pin 5 of the bad one is -3 volts. Pin 5 of the good one is -3 volts. Pin 6 of the bad one is -3.4. Pin 6 of the good one is -2. So there's a difference there. Nicholas says make it oscillate. Okay. Check cap between pin 5 and 6. You need to load the gates. Okay, we're going to make it oscillate, but I'm going to have to be really quick about it. How the fuck am I gonna do this? I need to hold both these on the driver and plug the RCA in at the same time. Okay. I really don't want to slip this, because if I slip and short these pins out, then it's bye-bye driver and bye-bye FET and all sorts. Fuck's sakes. I need more hands. Right, okay. So oh fuck. It's fucking slipping off. Alright. Okay. So I've just about managed to hold that in place. So I'm going to turn the amp back on. Okay, and I'm going to make it oscillate. Ah, fuck. I was resting my hand on the inductor and I got a shock. Solder some wires. Fucking, this is a fucking nightmare. Can I not troubleshoot the issue already? Can I not troubleshoot the issue already? Because I now, from looking at that, we can see that we have the wrong voltage. So on pin 6 of the good one, what the fuck? Now we have +2. +2 and -3. +1 and -3. Oh, it's sinking down, possibly. Yeah, it's sinking down. So if I make it oscillate, what does pin? I need to see what pin 6 changes to when it oscillates. Okay, so that actually becomes the wave. So pin 6 becomes the wave, and what does pin 5 do? Ah, pin 5 also becomes the wave. Okay. You need to measure with ref to pin 5. Okay. Yeah, I guess I could leave the RCA in the input. The only problem is it makes audio. So I don't know if that will change things. It probably won't change things. I could, yeah, okay, good idea. I'll leave the pin in the input. Okay, fine. Let's do that. All right. So leaving that in the input. Okay. So measure pin 6 in reference to pin 5. So this is on a good bank. And it's oscillating now. And wow, the voltage is kind of crazy high. So let's do that again and see. What should I be measuring? AC voltage or DC voltage? Pins 5 and 6 should have a cap on it. I have like fucking crazy high voltage on pin 5 and 6. Yeah, on pin 5 and 6, my multimeter tells me I have in excess of 600 volts DC. So maybe if I check it on AC mode. No, it's still, my multimeter still says in excess of 600 volts. So yeah, DC volts, it's in excess of 600, it doesn't read anything. The old days are best left in the old days. Like Pioneers, that's all old stuff. I won't be running Pioneers and stuff like that again. Like that's the old stuff. The videos are still there if you want to watch that stuff, but like with the car build now, it's all about digital designs, SQ front end, transmission line door cards, and a pair of 21-inch DDZs in infinite baffle in my boot on about 10k. That's what it's about now. Nicholas says that means the cap is not good. Okay. Should we check that on another side? So on the side that's good. So Nicholas, I was just checking that on the side that was good. So if I check that on the bad side now. So let's go ahead and check that on the bad. This is the bad side. So let's check that on the bad side. DC voltage. I have 732 volts DC on that one. On this one here, pin 6 reference to pin 5. This is another good side one. This is a good side one. I have fucking massive voltage again. Like it goes in excess of what my meter can read. And this one. No, there's nothing. I wonder if I killed the FET. I wonder if I killed the FET. It got too hot. Let's see. We're now drawing 7 amps, which we weren't drawing before. We were only drawing 5 amps. Oh, weird. There's some fucking... What the fuck? There's nothing on pin... There's nothing at all on pin 5 and 6 of this bank. What the fuck? Yeah, this is DC voltage. So DC voltage... Right. For people that are interested and trying to assist me get this thing fucking fixed. Okay. For people that are interested, measuring DC voltage with my multimeter of pin 6 reference to pin 5. So pin 6 is the positive, pin 5 is the negative. With oscillation, with RCAs into the amplifier to get the amplifier to oscillate. On this good bank, I have excessive volts, so higher than 600 volts DC. Okay. On this bank, I have the same in excess of 600 volts DC. On the bad bank, I have a number on the screen which reads 730 something volts DC. So that means that that one is different to these ones. On this bank over here, that's been perfect the whole time and nothing's heating up and it's beautiful, there's absolutely nothing on pins 5 and 6 whatsoever. They're completely dead stone cold. There's no waves on them whatsoever. Okay, so then, let's test our theory. So then, if what Nicholas is saying, if it should be in the range of 10 to 15 volts DC, if that's correct, let's plug our good board in. This is our good board. Okay, let's load this back up with some FETs. And let's put the resistor back on there. And let's measure what the DC voltage is on the good board. And that will tell us what it should be. Yeah? Cool. That's a plan. That is a plan. I feel like we're honing in on the issue. Seeing all these different results on pins 5 and 6 has given me new hope to finding the problem. Because I can quite clearly see that something is not right on the bank that's heating up in regards to pins 5 and 6. There's something different about those ones that's obviously possibly causing a problem. So I like that. I like that we're finding something that's different. When you find things that are different, that's a good sign. It means you're on the right track. It's very probable that my voltmeter can't handle the higher switch wave frequency. I could run it through an inductor. So I've got a spare inductor here. So I could solder one of the inductor, one side of the inductor to pin 5, and then measure from the output of the inductor to pin 6. So that would get rid of the switch wave frequency and would allow me to measure it, I guess. Okay, so this is our tasty good board. So I'm going to load up some FETs into our tasty good board. Just real quick. Shouldn't take more than a minute to load up some FETs into our tasty good board. And let's compare what we should have on pins 5 and 6 on our tasty good board to our stanky bad board. Tasty good board, stanky bad board. How do we get in touch if you want you to repair an amplifier? If you are based in the UK, then you can message me on my NSV Audio Facebook page. Just search for NSV Audio and send me a message. If you're not based in the UK, unfortunately it's not cost effective to take on work from overseas, because once you've shipped the amplifier to me and then back, the whole process costs more than the amplifier is actually worth. Okay, FETs are loaded into our good board. So let's swap out our good board and let's compare to see whether the voltage on our multimeter is still into the 700 or greater volts DC, or whether it's actually something sensible like, as what's suggested, 10 to 15 volts. Oh man. So I need to steal the driver board from this. I need to steal the driver board, that's going in the new amplifier. And I need to steal two driver ICs because I'm two down, so still two. Yoink. And yoink. Put the bad one to one side for a moment. Do you think earthquake subs are any good? Some of them are okay. Earthquake are like, they're okay. I don't go crazy for earthquake stuff. Okay, so let's get the thing turned on and oscillating then. Let's get our, I'm just going to get our probes here so we can see the wave oscillating and stuff. Low side and high side together. App Store says I've been watching a very long time. Cool, man, that's wicked, thank you. I'm glad my videos have somewhat entertained you over the years. Alright then, so let's turn her on and we're going to measure some DC voltage across pins 5 and 6 with our multimeter. Cool, so she's up and running. So now very carefully, because it's on and I don't want to short the pins out, because if I do that's going to be bad days. So measure pin 6 with reference to pin 5. Let's compare between all of these here. No, I'm too wobbly. I'm too chicken. I'm going to turn her off. I'm going to plug the RCA in permanently. I'm going to set up the probes before I turn it on. Alright, there we go. Okay, so once again, my multimeter shows it's over 600. Now, we don't necessarily need to know the number. We just need to see what the differences are. So we need to compare. We need to compare the good board to the bad board. So on the good board, if we measure the voltage between pins 5 and 6 like this, on my multimeter, it should show up as excessive voltage 1 on my multimeter. Excessive DC voltage. That's how it should read. So let's try this bad one again. No, this isn't the bad one. Sorry, this is another bank. So I'm going to try another bank over here. So this should also read excessive voltage, which it does. It reads excessive voltage. And now if I check another bank over here, where are we? 5 and 6. This one reads excessive voltage, good. And this one over here, last but not least. That also reads excessive voltage. Okay, so we know that there are still some issues then on our bad board because we don't have those same consistent results on the bad board. Now, just to see what's actually going on pins 5 and 6, what I'm going to do is I'm going to take my 2 multimeter probes. I'm going to overlap the waves on my scope here. So I'm going to turn my scope up to 50 volts on both of my inputs, and let's see what the multimeter, what the scope sees on pins 5 and 6. Okay, it sees this. So the scope sees 2 waves that are slightly different to one another. Now, Nicholas was saying to me to measure the DC voltage between those 2, which I can't obviously do on my multimeter, but I think I could do on my scope. If I go to my scope and I push the button here, which is called channel math, I can subtract channel 1 from channel 2. I might need to add them actually. Let's try subtracting them first, and it might give me some interesting results on the screen as to what's between these 2. So by doing math with the channels, I can see what's between the 2. Oh wow, okay. Okay. Perhaps I need to add them rather than subtract them, see what that does. Okay, no, I think I do need to subtract them, but I need to subtract them once the amplifier is already in operation. I need to remove the RCA from the amplifier here, so that it's not doing audio, so that it's just doing its switching stuff. So I need to be very careful now not to short anything out on here whilst it's turned on, whilst I attach my scope probes. Okay, that's more like it. That's more like it. So Nicholas, that is the small square wave that pins 5 and 6 is seeing as offset. So I don't know what voltage that is, because my scope doesn't give me a voltage reading for it doesn't give me a voltage reading for channel math, but we could probably work it out with the divides. So if let me zoom in on that. I'm going to zoom in to 10 volt divide. I hope this is interesting for you guys. This is fucking interesting for me. I'm learning a shitload now. Okay, no, it's zoomed in slightly too much. If I zoom out a little bit. Oh, no, still zoomed in a bit too much. Zoom out again. Because I think it only works on 50 volts divide. Yeah, okay, it only actually displays itself to me on 50 volt divide. So the bottom, so this is going from ground to negative something. So if it's 50 volt divide, I think that this second line here is 50 volts. So then I think that this one is 25 volts. So then in between this one and this one should be 12.5 volts. So that works out about right. That's about what Nicholas was saying. So we have 12.5, we have a 12.5 volt, we have a 12.5 volt square wave, peak to peak, 12.5 volt peak to peak wave, I think, on that. So this is the good amplifier, remember, this is the good board. So I'm just going to compare that to the other banks and see whether that is that matches up with all the other banks. So again, I'm going to put pin 5 on here. I'm going to have to turn the amplifier on and trip it into operation with the RCA first. Cool, okay, we're in operation. So pin 5. Okay, yep, that looks the same. Looks good. Now let's go over to this side. I think this is all going to be exactly the same, don't you? I think this is all going to be exactly the same. Okay. Interesting. Oh no, I'm doing the wrong pins. Pins 5 and 6. Okay, so on the other side, it's actually going up. Have I got my probes backwards? I think I probably have my probes backwards. Yeah, okay, so the other side is exactly the same. And the last batch, the last bank here should be the same as well. Yes, okay, so that is what we should see. That is what we should see on the bad board, but we don't. I know for a fact we don't see that on the bad board. So, we are homing in on the problem. We're going to get this fixed tonight. I can feel it. I can feel it now. Thank you so much to Nicholas for pointing me in the direction of pins 5 and 6 and having needing the offset on there. I was not aware that that was a thing with these driver ICs, and now I do. Now I understand a bit more about these driver ICs and what I should have and what should be where. So that is awesome. I am learning. And I hope you are too. Interesting. So this is the good board. This is the good board. This inductor is actually getting hot, well, it's warming up, and the others are staying cold. So this is the good board that works fine. But interestingly, this inductor is warming up, and the others are staying dead stone cold. Why would that be, I wonder? Maybe this one's shorter. I'm going to, just out of interest, a bit later on, once we finish this, I'm going to actually check the inductance of these 4 inductors, make sure they're all the same. Because I call this board the good board, but this one did blow before, but it just doesn't have as many issues. What voltage does my power supply go up to? My bench power supply, which is here, goes up from 0 to 16 volts officially, but I've got a bit more than 16 out of it before. It goes roughly up to about 17 or 18, depending on the current. Yeah, it's about 16 volts. Okay, so let's swap all our parts back. So this is the board. So now we know what should be on pins 5 and 6. So let's take all our parts back, including our drivers. Put this back to one side. Pick up our bad board. This is the one that's bad. Drop the driver board back in place. Drop the drive ICs back in place. Okay, good stuff. Nicholas is an electronics engineer. He's fucking good at what he does. My goal is to get as good as Nicholas. That's my goal. Nicholas is a godsend on my channel and my live streams. He helps me out so much. I'll tell you what I need. I need a foot pedal for my frequency generator. I need a separate foot pedal on my frequency generator that I can press to turn the switching on for issues like this where the FET heats up within like a few seconds. Okay, well I know roughly what should be on these pins now, so let's this is going to look a bit different because we've got audio going in, so it's going to look a bit more messy. But I can't have the amplifier turned on for that long while I remove the RCAs. So what I'm going to have to do is just do it like this with the audio, and it's going to look a bit messy on the scope, but we're going to have to just pretend the audio mess isn't there. So we're going to have to pretend that the audio mess isn't there and just look for the negative voltage on the scope. So this is bank number 1. I'm going to call this bank number 1 up here. Bank number 1. What do we have on pins 5 and 6 with our scope? Okay, so that is correct. We have the correct stuff on pins 5 and 6 with our scope on that bank. Let's check the bad bank. This is where it gets interesting. This is bank number 2, bank number bad. Oh shit, it actually looks okay. Okay. Well, that's strange. I was really expecting that to not look right. Okay. Bank number 3. Over here. Also looks okay. And bank number 4. Now this bank is the one that could actually have the issue, because this one there wasn't anything on. Yeah, so there's nothing at all on this one. So this is fucking interesting. This is brilliant. So the FET that's getting hot is over here. But I wonder if the issue causing this FET to heat up is actually over here. Yeah, Nicholas, the reason that has noise on it is because there's still audio going in. So I can't do it quick enough. I can't remove the RCA quick enough. So the noise was there on the good board as well when it had audio going in, but I can't turn it on, remove the RCA, and then go and probe it quick enough. The FET gets too hot. I don't like it. So there's nothing on pin 5 and 6 down here on this bank, which we haven't looked at before. So I wonder if not having anything on this bank is causing this one to fuck around, possibly. I don't know. Really strange, really interesting. So apparently there should be a capacitor between pins 5 and 6. So let's use our multimeter now to find out what is actually on pins 5 and 6 and where that thing is. So diode mode setting, we're going to probe pin 5 and see what pin 5 is connected to on the board here. I'm looking for a capacitor. Can't seem to find one just yet. Okay, it's connected to this diode. Yeah, the large spikes were due to the audio. That was the same on the good amplifier as well. The large spikes and the noise were due to the audio. Right, I'm looking now for the capacitor that is on pin 5 and 6 down here on this bank that we haven't looked at yet. Okay, the drive resistors on this bank are fine because I went around every single one of them checking checking the drive resistors. So I might need to check this cluster of capacitors here. So pin 5 and 6 are going to end up being the top ones, the top 2 and 3 in. So these two here. So let's zoom in over here. Okay, so this here is pin 5 and 6 over here on the back of the bank that didn't have anything on pin 5 and 6. So here we go. There's a capacitor over here that this is connected to. It's connected to two capacitors over here. And pin 6 is connected also to this stuff. So it's possible that this diode here is hang on. Oh no, this is a resistor. That's a 10 ohm. That's a resistor. Okay. So what is it that's causing there to be no drive on pin 5 and 6 over this side? I'm just trying to find that out. I'm just going to use my scope for a little bit of testing with it plugged in. I want to see where it loses it. There must be some component where it loses it. It must lose it somewhere. So there's nothing there. There should be something there. So let's compare it to a good bank. Let's compare it to a good bank. So there's nothing on that side of the diode. There's nothing on that side of the diode either. Nothing on that side of that diode. Doesn't seem to be anything on that side of the diode either. So why are you not getting back? Why are you not getting back to the drive IC? Where does it find its path from? Right, let's try this resistor here. Okay, it's very small there. So it should be high there and it's very small. Aha! Okay. I think I found the problem. Possibly. Maybe? Have I found the problem maybe? No, what's that? That's low side drive. Okay. That's high side. Oh, rear. Ah, sad times. So the FET that was getting silly hot just died. The FET just died that was getting crazy hot. Ah, that's annoying. Okay, so we need to swap that FET out. We might have killed the drive IC as well. Yeah, low side's working. I explained how I came up with the channel name literally 5 minutes ago. I'll go over that again in a bit. I'm just very focused on this just at the minute because I'm feeling like we're almost there with it. So it just killed one of the FETs. The FET that was getting really hot, I think it just killed it because it's now showing a 70 ohm resistance between that FET. So I'm trying to troubleshoot this at the same time that it's getting crazy hot. So I keep heating it. This is really quite difficult to work on while it's getting hot like this. Ah shit, I think I killed the driver as well. Because we still have 76 ohms on the driver. That's odd, the FET itself reads okay. The FET reads okay, but the driver died. Rare. Okay. And this is the driver that I soldered in as well, so I've got to fucking desolder it now. Check resistance from pin 7 to high side and high side to FET source. Okay. Now let's remove this dead driver first. At least I think it's the driver that died. Either way, I want to remove it anyway because I want it on headers because it's easier. I want it back on its headers. Oh, we're so close, but we took a step backwards. And what's interesting is it killed something on this section just as I touched some via over on the other side of the board. I touched one of the vias on the other side of the board, and then it just decided to kill this this something on this side. So I wonder if it's a dead via on the other side of the board that's causing all of these problems. App Store, you should be able to scroll back in my live stream. Does it allow you to do that? My live stream should allow you to scroll back through the stream and watch bits that we already streamed. I have it set up so you can do that. Alright, so if the driver died, then there are 70 ohm resistance that was between the gate and the source should have disappeared. Yeah, so it was the driver that just killed itself. Alright, fine. So let's put our headers back in. And let's steal a driver from the other board, just temporarily. But I think I'm gonna continue troubleshooting without having to turn it on, because I don't want to kill like loads and loads and loads of these driver ICs. Interesting that the driver died though and not the FET. That's really interesting. Usually it's the FET that dies because it's getting crazy hot, but no, the IC died. The actual driver. That's really interesting. Okay, so let's steal a driver from the good board. I have 2 drivers left. I have 2 spare drivers left. So I can only spare 1 more. One more can die, and then that's it. Okay, that's better. That's better. I'm just going to check the FET in my tester to see if the FET, make sure the FET didn't die. It might have done. It might have killed it. No, FET stayed fine. Didn't die. Okay. Interesting. Okay. So, I'm just going to yeah, this is really interesting now. So, we're looking for Y pin 5 and 6 on this driver IC at the bottom here. Doesn't have anything on it. Doesn't have any high side stuff on it. So we need to look at where it gets it from. So 5 and 6, let's flip this over. So now over the top. Yeah, lead-free solder is rubbish. I use 4060. I actually prefer SMD. Beverage, check the resistance from pin 7 to the high side gate FET. Alright, so pin 7 to the high side gate FET. Oh, the resistance is on all of these. It's 72 ohms. So I can check that for you again. I've done this one many times. So let's see. resistance from pin 7 to high side. What am I doing wrong? 1, 2, 3, 4, 5, 6, 7. Right, so yeah, 72 ohms. And the resistance for and pin 5 high side, sorry, check resistance from pin 7 to high side get FET, and pin 5 to high side FET source. Pin 5 to high side FET source is a direct short. Which is what it should be. Well, not a quite a direct short. It's like 1 ohm. Which is what it should be. Double stack boards, yeah. So what I'm going to do now is I'm going to take our good board and I'm going to follow the resistance path of pin 6 and pin 5 and see where there's any differences. So pin 5 here we should have continuity. Pin 6 we should have continuity to this diode. And I understand that you can't see shit of what I'm doing right now, but I don't have a camera angle that can get this on camera. So let's check. Do we have that there? Yes, we do. And then we should have from this diode to this diode, we should have no reading there, no reading there. Should have about 412 there, which we have exactly the same thing here, pretty much. 409 and 411. It's pretty much the same. So then where does this one go? This is then meant to go to... Where does this go? Okay, this then goes to this 10 ohm resistor. So let's check it goes there. Yes, it does. The other side of this 10 ohm resistor then goes to... Where does the other side of this 10 ohm resistor then go to? I'm doing old school measuring now. Okay, the other side of this 10 ohm resistor goes up to this capacitor up here. So let's just make sure that the same thing happens on this bad board. I'm just comparing traces. I'm trying to find broken traces at the moment. Okay, yes, it goes up to this capacitor. So I'm wondering whether this capacitor is the issue. And then it goes from this capacitor. Where does it then go? It then goes from this capacitor to... Let's see, where does it go from this capacitor? It then goes from this capacitor to up here. We have some smaller capacitor by the looks of things, C601. So let's check that it does that. Yeah, it does. And then on the other side of this capacitor, it then goes to where? It then goes to R601. Okay. So let's check it goes to R601. Yeah, it does. And then from R601 we should have a resistance of... R601 should have a resistance of... Let's have a look. 2.17 kilo ohms. Which it does on here. Yeah, that's correct. It then goes from this R601... to this diode, and then from the other side of this diode it then goes to, where does it go from the other side of this diode? Then goes to pin 12. It goes to pin 12 on the other side of that diode. Man, this is some fucking long ass chain. I was hoping to get to like gate or source or drain or something. Oh, fuck's sakes. Okay. My stream's gonna die. Just give me 1 second, guys. Okay, so I'm gonna what I'm gonna do is I'm gonna leave it there for this evening. I completely forgot what the time was. I've got loads of shit that I've got to do this evening as well as this. So thank you very much for your help, and we are much closer with this. Many thanks to Nicholas. We need to find out why this doesn't have the waves on pins 5 and 6. When I find that out, I'll do another live stream so that you guys can see what the issue was, so you know what to look for on similar amplifiers to this. Okay, sorry about that, guys. Whenever my phone rings, it disconnects in the next stream.